Hello everyone! I hope you all are enjoying our online conference and you've seen a lot of nice and interesting features so far. Also, a very warm welcome from my side to be here with us in these special circumstances. My name is Jannes. I work for SCIA as a customer service engineer, and I will give you an overview of our most important new concrete developments in SCIA Engineer version 20. Let's start with a brief summary of the topics that we will handle. Firstly, I will talk about our new bill of reinforcement and moreover its implementation in the bill of material. Secondly, I will show you our new reinforcement templates for the T and L-shaped concrete cross-sections. Next, we'll have a look at the new representation and distribution of the provided reinforcement. We'll elaborate on the new and improved method to design column reinforcement, namely by iterative approach using the checks. Further, the shear force reduction above supports will be handled. And at last, I will talk about the pre-stress functionality being migrated to our 64-bit version. So in our previous release, we came with a completely new bill of material. Today, I'm glad to announce that in line with this, we also developed a new bill of reinforcement. This bill of reinforcement takes into account all 1D user reinforcement and can be accessed either separately from the concrete menu or integrated in the bill of material together with all other materials. We included the same logic as for the bill of material, which means that you can also perform price estimation. The unit price can be adjusted per material or directly defined by the user. In addition, coefficients for increasing are added. The reason for this is that the bill of reinforcement is calculated with the net reinforcement, so possible losses, like cutting and welding, can be accounted for by coefficients. The sorting can be done by material, cross-section and member. Here on the left, you can see the bill of material with sorting by material. The reinforcement table gives the unit mass, length, and eventually the price. On the right, you can see the results with the sorting by cross-section. For the reinforcement, sorting is done by diameter and type. And the sorting by member gives a more detailed output of every reinforcement layer in the 1D elements, together with a summary table per 1D element. We received quite a lot of questions regarding this new development. We reworked our current reinforcement templates for T and L-shaped sections to be more compliant and useful with the RIP functionality. In version 19, the shear and longitudinal reinforcement were always calculated in both the web and the flange. We added two options: shear reinforcement in the web only, which means that the stirrups are calculated in the web and the longitudinal reinforcement is calculated in the web and flange, and both the shear and longitudinal reinforcement only in the web. And here is a new template for L sections. Next, we changed the distribution, or better said, the representation of the provided reinforcement. In previous versions, corner bars were counted in both sides of the section, coming together in the edge, for instance, horizontal and vertical. If we take this example, it looks like every corner bar is used twice. If you count all bars, you don't find the actual amount of bars, so 10 instead of 6. And the reinforcement templates, you can choose the axis of design, Y or Z, and the corner bars are as a consequence only counted in this direction. This means that you can easily count the real amount of bars from the table. Here, for instance, you can choose the main direction for design of a rectangular section. Column design by check. Maybe you have already noticed this message, or you might have noticed a difference in the design value and the unity checks. For design purposes, we make an assumption that all reinforcement is placed in the middle of an edge. This means that the design reinforcement only has a resisting moment capacity around one principal axis. Reinforcement which is not placed in the middle of an edge, corner bars for instance, have a resisting capacity around two directions, the Y and Z directions. However, for designed reinforcement, this second capacity is not considered. This is also the reason why in some cases you might find a lower value for the unity checks while in the design the reinforcement was just sufficient. In some cases, especially for biaxial moments like columns, this led to an overestimation of the required reinforcement and thus an uneconomical design. With the design by check option, the design values give a much better outcome. For this, an iterative approach runs in the background by designing reinforcement, doing the check, adapting the reinforcement, and so on until a good value is found. It's sort of backwards engineering to find an optimal design. Deactivating of the shear check above supports. This feature was already implemented in the design comment. Now we extended this functionality such that the setting also influences the shear check. If activated, the shear check is kept near the supports and only the detailing provisions on VRD max are checked. VRDS is deactivated. As a user, you can choose to apply this rule within the size of the support or up to a distance d from the face of the support. Here we can see the shear check above the middle support has decreased and became flat. Okay, we arrived at the last topic of my presentation, namely pre-stressing. Pre-stressing was already available in SCIA Engineer for some time. However, during the migration to our new post-processing environment, needed for the 64-bit version, pre-stressing was not redeveloped yet. I'm glad to announce that pre-stressed and post-tension tendons and beams are now available in our 64-bit version. This migration leads to a faster calculation compared to the old solution. You can now calculate buildings and bridges with post-tensioned elements. Strand patterns can now be used to analyze precast bridge beams, roof elements, hollow core slabs, and beams with constant or variable cross-sections. For the pre-stressing checks, we have made a link with IDEA pre-stressing. Post-tensioned concrete can be checked on ultimate limit state and serviceability limit state. Reinforcement bars can be created for constant or variable sections. The ULS checks cover bending and normal force, shear and torsion, and an interaction check. The SLS checks cover the crack width or decompression, and the stress limitation check for tendons, traditional reinforcement, and concrete. Further, also the detailing provisions are looked upon. Those ULS and SLS checks can be run by one single click, giving you a good overview of the design. In case the checks are not sufficient, or if you want to have additional information or help, the error warning and notification system will guide you. To summarize, here you can see all possibilities for post-tension structures. Besides speed improvements, you might notice that the reinforcement stress, interaction, and detailing provision checks became available now. Reinforcement design together with post-tensioning is not possible yet, but we are working on it for the future. So this was in a nutshell what you can expect from our concrete services in version 20. Let's find out how it works on a practical example. I have this simple structure with some loads. After calculation, we can go to the concrete menu and launch the reinforcement design. I'm going to calculate the provided reinforcement and then we can convert the results to real bars. Next, let's check the bill of reinforcement. The results are displayed in the graphical window, but a better view can be extracted from the preview. Here we see a bill of reinforcement with sorting per material giving the masses and lengths. Adding a coefficient will increase the concrete quantity and reinforcement lengths. Further price estimation can be activated, and the unit prices can either be adjusted directly or can be taken from the material database. Here we find the price per unit. Besides the material tab of sorting, we can sort per cross-section, so per cross-section and per bar diameter, and per member. This option gives the most detailed lists with reinforcement layers per member and type, longitudinal or stirrups, and a summary per member. The bill of reinforcement is also integrated in the bill of material, where other materials such as steel, aluminum, timber are listed. Next, let's go to the renewed templates. For the T section, we can choose for reinforcement and stirrups only in the web, both in the web and the flanges, or stirrups only in the web. The same options are given for L sections. Okay, now we will display the reinforcement design again. Maybe I can hide the reinforcements because otherwise the results are not clearly visible. So, we have a design with two bars in upper and lower side and one bar on the left and right. In the detailed preview, we can see that indeed in total there are 6 reinforcement bars. So the corner bars are assigned to the upper and lower edges. If we change the design direction for the rectangular beam template, let's change it to main reinforcement in the Z direction. The corner bars are assigned to the left and the right edge. On to the next topic, design by check. First, I'll make sure this option is deactivated. The reinforcement design is performed according to the previous method, a simplified approach. We can see that the reinforcement is calculated in the middle of the edges, and the whole calculation is described. Now let's activate the design by check function. This is an iterative approach to find an efficient distribution of the reinforcement. We can now also see that the output has changed and the checks are showed. Let's talk about the shear and torsion check. Performing this check gives a unity value for the beams above the column. If we apply the shear force reduction above the column, within a distance d from the face of the columns, the unity check is well below unity. For more details, we can open the section check above the column For the shear check, the torsion check, and the combine check. Only the detailing provisions for stirrups should be checked in the shear part. So, thank you everyone for your attention. If there are any questions, please feel free to ask them.